All right, in this video, let's review how to factoring polynomials. So I write down factoring greatest common factor, factoring by grouping, trinomials, and difference of square with factoring sum and difference of cubes. So let us review real quick. So let's begin with the greatest common factors real quick. All right, so let me explain the word greatest first, okay? So I wrote down these three numbers here on the side, 12, 24, and 36. So what I'm going to do is break them down using prime factorizations. Only write down prime numbers here. So what times what is 12? Normally students say 4 times 3. So that would be 2 times 2 times 3. 24 is 4 times 6. So that would be 2 times 2 times 2 times 3. 36, students say there's 6 times 6. That would be 2 times 2 times 2 times 2 times 3 times 3, right? Do I count too many? 6 times 6? Yeah, I count too many of them. 6 times 6 is 2 2s and 2 3s. All right. So greatest common factor is counting the repeated factors only. So if you count the 2's repeated between all three numbers, you count that one time. Another set of 2 repeated one time, you count that again. And 3 repeated, you count that one time. So most of the students know by looking at 12, 24, 36, you can say the greatest common factor is 12. So that's the largest common factor. So if you say simply 2 is a common factor, I agree. 4 is a common factor, I agree. 6 is a common factor, I agree. But the largest, the greatest common factor got to be what? Got to be 12. So if I break it down like this using prime factorization, for greatest common factor is counting for the repeated factors. So most of the times I'm asking students to simply just looking at the numbers and know what the greatest common factors are. So if you look at 6, 45, and 21, the greatest common factor got to be 3. All right. For the variables, make sure the variable repeated between all your terms. If it does, then we choose the smallest exponent. So x repeat between all three terms, the smallest exponent is 3. Y repeated between all three terms, the smallest exponent is y to the first. So I just am going to write y. So my greatest common factor for this problem is 3x to the third, y. Now I will write times parenthesis. What's inside the parenthesis got to be the leftover for the three terms. Okay, just like right here, whatever I don't circle is what's left over. Okay, it's basically what's left over for each terms. So 3 will go into 6 2 times. So this is like a division basically, because when I break down the 6x to the third, y to the third, it's got to be 2 times 3 times x 3 times, y 3 different times, right? So so that means if I will wrote all three terms out, okay, then 2 is not going to be circled, all right? All three of these x will be circled because it will repeat with other terms, and only one of the y will be circled. So what I did not circle got to be the leftover, which is 2y squared. So the way we say it is, since this is a division, we say 3 will go into 6 2 times. All right. You take all 3x to the outside, so there's no x left for your first term. You only take one y outside, then there's actually 2 left in the inside. So the way I'm saying it mathematically is actually saying 3x to the third y will go into the first term so many times. All right, so 6 over 3 is 2. Here is basically quotient rule for exponent. The x's will cancel out, and a 3 minus the exponent 1 will be y squared. So it's basically a division problem. Okay, factoring is basically a division problem. So instead of writing like this, we just kind of doing it by looking at it and thinking about how many variable I'm taking outside. So that's how many left in the inside. So when I'm taking the variable outside, I am subtracting the exponents. That is basically saying subtracting the exponent. All right, 3 going to positive 45, I believe it's positive 15 times. Take 3x away from 4, one of them is left for the second term. Take 1y away to the outside, 1 is left for the second term. 3 going to negative 21, negative 7 times. Take all 3 of these x to the outside. No x left for the third. And take the only y to the outside. There's no y left over for your third term. So this must be my answer. Okay. Now the next question is, how do I know I factored completely? A lot of students says we will need to multiply it back out. So let me use that same 3 number here for example. I'm just going to add some variable with it, okay? So if I got 12x to the third plus 24x squared plus 36x, if you say the greatest common factor is only 2x, so that will leave you with 6x squared plus 12x plus, what was that, 18? So if you multiply this thing back out, of course you're going to get your original problem back. But if you actually look closely at the coefficient of the 3 terms, you can actually factor out another 6. So if you factor another 6, then the greatest common factor here should be 12x. Okay. Excuse me. So multiplying back out is actually not the answer as far as asking how do you check your answer. Okay, we normally don't check our answer by multiplying back out. The way we do it is by checking what's inside the parenthesis. Okay, to check our answer, we check what's inside the parenthesis. See if what's inside the parenthesis is factorable or not. So if I go back to our answer here, if you look at the 3 term, there's no greatest common factor between 2, 15, and 7. And there's no variable repeated between all 3 terms. So this is how I know I actually factored completely. Okay, that's what that means, by factoring completely. So I know a lot of students being taught by multiplying back out to check the answers. The correct way of saying it is really about checking what's inside the parenthesis. Now the next one is factoring by grouping. Factoring by grouping is a very specific type of factoring problems. It requires you to factor twice. Okay, 2 basic characteristics of a factoring by grouping problem. You got to have 4 unlike terms, and there can be no greatest factor between all 4 terms. So just like the naming itself, factoring by grouping, we got to do grouping first. So the way we do grouping is we can group the first 2 terms and the last 2 terms first, or sometimes we can do the first and third, second and fourth. You can group them differently, but the easiest way initially is to group the first 2 and the last 2. Let us change this problem to a plus sign right here. All right, group the first 2 and the last 2. So step number 2, factoring out the greatest common factor between the first 2 and the last 2 terms. So between the first 2 terms, I know I can factor out a 4m squared. So what's left over in the 2 parentheses got to be 5m minus 11. Oh, sorry. Got it backwards again. Factor of 5m squared. So what's left over in the 2 parentheses is 4m minus 11. All right. So the last 2 terms has no greatest common factor other than 1. So I want to factor a positive 1. And here's the reason why. So step number 3. Once I factor out the greatest common factor between the first 2 and the last 2, then there should be only 2 terms left. And what's inside the parentheses should match. So basically, I'm purposely factoring out the greatest common factor for the last 2 terms so the 2 parentheses will match. So if I factor a positive 1 here, then positive 1 going to positive 4m, still positive 4m. Positive 1 going to negative 11 is going to be negative 11. So I'm purposely factor out a positive 1 so my 2 parentheses will match. Because once the 2 parentheses matched between the 2 terms, then the greatest common factor between the 2 terms now is actually 4m minus 11. It's 2 terms representing 1 greatest common factor, so I put them in the parentheses. So if I take the 4m minus 11 to the outside, what's left over for my first term got to be 5m squared. If I take the 4m minus 11 to the outside, what's left over for the second term got to be positive 1. So my answer, 4n minus 11 times 5n squared plus 1. That's how we actually do factoring by grouping, okay, type of problems. All right. Now, to be honest, there's a lot of different ways to factor trinomials. The way I'm going to show you here is called the trial and error methods. It's basically just another way of saying I'm going to do Fourier method backwards, okay? Doing the Fourier method backwards. So in the previous video, I mentioned what a true trinomial is. A true trinomial is the last three terms of a polynomial. It got to have exponents that says 2, 1, and 0 power. Okay, gotta say 2, 1, 0 power. Or it can actually say 0, 1, 2 power. Okay, that's still considered as the last three terms of a polynomial if I write it as ascending order. So here are the 5 steps on how to factoring trinomial. So I'm not gonna read through this right now, but instead what I'm gonna do is say what's in here by using this example. Okay, so the first step is always see if you have a greatest common factor between your three terms. So this is a trinomial, 2, 1, 0 power. No greatest common factor, so I write 2 parentheses right away. Step number 2, find all the factor that makes the first term and the last term. First term is 5, so that will only be 1 times 5. The last term is 6, which is 1 times 6 and 2 times 3. All right. So starting from the bottom, write the factors you just found inside the 2 parentheses accordingly. The factor of the first term 5 got to go on the front side of the 2 parentheses. The factor of the last term should go on the back side of the 2 parentheses. All right, step number 4. Now make sure the inner and outer combined will give you the middle term. All right, so inner and outer combined. Remember Fourier method. Right now, my outer 1 times 3 is 3. My inner 2 times 5 is 10. Can 10 and 3 combined somehow give me my middle term 7? Yes, I can if I subtract them. So step number 5, how do we assign the signs for the 2 parentheses? If the last term of the trinomial is positive, if the last term of the trinomial is negative, and that's what I got, a negative on the last term. So if the last term of the trinomial is negative, number 1, it means the inner and the outer must be subtract to get to the middle term, that's what I did. Number 2, the choices for the sign is going to be 1 positive and 1 negative. All right, so it depends on the middle term. If the middle term is positive, that's what I have. If the middle term is positive, then I will assign the positive to the bigger of the 2 inner and outer, because I need more positive term than negative term combined to end up with a positive 7 in the middle. All right, so now once I know my outer got to be negative 3, then that will be 1 times negative 3. So the other parenthesis got to be positive. So now I have a negative 3 on the outer, positive 10 in the inner. So my inner and outer combined will be about positive 7. Now I can put my x back in there, and I'm done with the problem. X plus 2 times 5x minus 3. Now, should you need to FOIL this out again to see if you come up with the same problem? Not necessarily, because you just did the FOIL methods backwards to actually factor this. So once you're done, you basically it's done. All right. Now let's try another one. Okay, 20b squared minus 47b plus 24. So no greatest common factor between the 3 terms. All right, so 2 parentheses right away. Find all the factors, step number 2, of the first term and the last term, 20. So normally I always use the 2 numbers that are closest together, multiply. That will give me that will actually give me my 20, which is 4 times 5. I got other factors, but I'm going to use this last one first. All right, 2 numbers multiplied together give me 24, and the 2 numbers got to be closest together as well. So that got to be 4 times 6. So let me write this down, okay? 2 times 10. All right, 4 times 5. So starting from the bottom, I will put the factor of the first term at the front of the two parentheses. All right. And I will put the factor of the last term on the back side of two parentheses. So here we go. Let me show you a little trick. When I put the second 4, when I put this 4 on the back side with the 4 that was already in the front, these two 4s together will actually give me a greatest common factor of 4 that I actually don't have in the original problem. So when this occurs, you know that 4 cannot be put here with that 4 in the front. So normally what students do is swap the two backside number. Put this 4 with the 5, put the 6 with the 4. But check it out. If I put a 6 with a 4 again, in this parenthesis, it also gave me another greatest common factor of 2 that I don't have. So that kind of tells the student that 4 times 6 doesn't work. So this is the wording trial and error methods. Okay, so I got to use the previous set, which is 3 times 8, give me the 24. So I'm not going to put this 8 right here with the 4 because that gave me greatest common factor again. So I will purposely know ahead of time to put 3 here, to put 8 right here. Okay, so that's how students kind of know the trick of where to put the backside number, because they're not going to put a number in the parenthesis where it's going to give them a greatest common factor that it doesn't have. And a lot of time, once you do this long enough, most students will just do this in their head. They can just put the 4 and the 5 at the beginning and begin to multiply and add and subtract in their head about the inner and outer. So right now, my outer is going to be 32. My inner, 3 times 5, is going to be 15. Can 32 and 15 combine give me my 47 in the middle? Yes, I can. How? If I add them. So the last sign, if the last term of the trinomial is positive, it means I will add. Okay? The inner and outer must be added to get to the middle term. And the choice for the signs is going to be positive, positive, or negative, negative. Okay, so how did I get my 47? Got to be adding to get to the middle term 47. So your last sign confirms how you're supposed to get to the middle term, okay, from the inner and the outer. So since the middle term is negative 47, then both of these inner and outer got to be negative, because term with the same sign, we add them to end up with negative 47. So both of my signs got to be negative, put my b in there, and I am done. 4b minus 3 times 5b minus 8. All right. Now, I'm gonna use the same exact problem up here. I'm just add another variable. Have you ever seen a trinomial look like this? 20b squared minus 47ba plus 24a squared. This is actually considered as a trinomial, just having using two different variables. Because if you focus on the b is 2 power, 1 power, and no power for the b. All right. The variable a, no a to the first, a to the second. So the exponent for the b is written as descending order. The exponent for the a is actually written as ascending order. So either direction 210 or 012 power is considered as a trinomial. So problem like this, we would just factor like a regular trinomial, and your answer would just gonna be how you see how we have 4b minus 3. Now I will have 4b minus 3a and 5b minus 8a. Okay, because I got a squared on the back. So this 24, negative 3a times negative 8a will give me the positive 24a squared. Okay, so it's still a trinomial. Okay, so just be aware of that. All right, let's do factoring of different squares. All right, got to recognize different squares. So normally different square got two terms where the two terms has different sign, and both terms got to be perfectly squared. So once you recognize it's a difference of squares, then the answer will just simply be a plus b times a minus b. So if you look at this example I have, this is actually not a difference of square problem right now because 20 and 45 are not perfectly square. But if I factor out the greatest common factor of 5, then what's inside the parenthesis should be 4x squared minus 9y squared. So that's the reason why earlier I said the way to check for your answer is always check what's inside the parenthesis. So what I got here inside the parenthesis is actually a difference of squares. So these are already squared. So what should be my A and what should be my B? Or what they should be is before they were squared. So this is going to be 5 times. Before 4x squared was ever squared, it must be 2x. Before 9y was ever squared, it must be 3y. So my answer will be 5 times 2x plus 3y, 2x minus 3y. Okay, that's all we do. Check what's inside the parenthesis. Now, when it comes to factoring the difference and sum of cubes, you just got to memorize the formula, okay? So before we do any factoring, before we do this example, if the problem is a plus sign, the first sign is always plus in the first parenthesis. The next sign in the second parenthesis is always opposite of the first one. The last term in the second parenthesis is always going to be positive. Okay, that's how you kind of memorize them. So 125x to the third minus 64y to the third, okay, difference of cubes. So this is a to the third minus b to the third. So the answer should look like a minus b. So I need to determine what my a is and what my b is. My a is just going to be what was my 125x to the third before it was ever cubed. So before 125x to the third was ever cubed, it must be 5x. Because, 5 times 5 times 5 is 125. Minus, before 64 was ever cubed, it was 4. Before y was cubed, it was just y. So my a is 5x, my b is 4y. So my answer should be a minus b, should look like a minus b times a squared plus ab plus b squared. So for my problem, it would be 5x minus 4y times my a got to be squared, which is 25x squared. Why is that? My a whole thing squared. This is actually a power rule. Okay, so I'm basically doing power rule without writing this out. 5 squared is 25. X squared is x squared. Plus, the next term should be my a times my b. My a times my b will be 20xy. My last term will just be my b, whole thing got to be squared, which will give me 16y squared. So all that is my answer. Okay, so we quickly review how to do some basic factoring type of problems. We'll factor quite a bit from time to time in this class. All right, that will conclude this video. Thank you for watching.